Hello everyone. So today I'm going to be guiding you through the visualization tools that we've got built into our SpotMap software that will allow you to do better, more accurate work. Now, as I mentioned on my other videos, you can get a free trial of our SpotMap software on our website, and I'll put the link in the description below. So if you're interested in trying out our SpotMap software using images from your own lab, please apply for our free trial and get in touch. So data visualization and the data visualization tools that we've got built directly into SpotMap are designed to make it easier for you, the human user, to be able to distinguish between spots and background, to be able to work out more finely where spot edges are, and generally be able to work with your data better, quicker, easier. So the first data visualization tool that we've got built into the software you'll see is our 3D view at the bottom here. Now this is fully responsive. It moves. You can see I'm just running this on quite a low spec laptop, I would say, for this kind of purpose. But you can see it tracks one-to-one with the data. It's very responsive, and as I move in to look at my spots, you can see obviously we zoom in and the data moves with it. And I can, if I want to work more with the image, I can drag my 3D view down or even turn it off within the display options, or I can bring it up to fit more of the screen in. But you'll see that this 3D view is always a view of what's in your main window here. So it makes working with your data, both the spot level and the data level, much easier. Now I say data level because the human eye has quite low sensitivity to detecting subtle changes in grey levels in grayscale images that come off scanners, just like these 2D Western blots and gels. However, if you look at the actual data, which is what the 3D view is generated from, you'll see that there are peaks or there is signal where you may not necessarily be able to view it. Another kind of difficulty in doing this work is that everyone's vision is different and everyone's computer monitor is different. So when you're making software to do with kind of visual analysis like this, we thought it was prudent to be able to build these tools directly into the software to be able to cope with different manufacturers of monitors, different specification levels of monitors. Obviously, higher end monitors are able to display with greater kind of resolution sensitivity, and to be able to work with all of the operators, all of the humans that are part of the life science workforce. So that's why we've gone as far as to put all these data visualization tools in. So you can see on the 3D view that if I want to work with my spots in this view, as I start to move around the changes that I make within the kind of the flat image, the non-2D image, those are represented in the 3D view as well. So if I come and zoom in and I can change kind of the intensity of this kind of Z scale here, I'm just using my shift and mouse roll here. When I select a spot, I can see that it turns orange. And as I want to split spots, I can see actually on the kind of the 1D view and on the 3D view, I can see how the operation I'm about to perform, such as splitting spots, is going to change my data. So you can see I've split this spot here because there's two distinct areas of signal that the software has just kind of merged together. And that'll be based on the detection settings that I've used and the auto splitting parameters, which I could have changed. But it allows you to work with both sets of data, the normal image and the 3D view, which kind of more sensitive to data and changes in data simultaneously. It can save you a huge amount of time and a lot of back and forth between different operations and within your workflow. And it also allows you to reduce your interoperator variability if you can kind of have all of those views available to you at once. Even better if you have a kind of like a 4K large screen monitor, you'll be able to work with these images really nicely in all kind of views using that kind of setup. So that's the 3D view, and I've got another video on the ability to export kind of your 3D view, your spot outlines, things like that, if you want to include them in reports or presentations or publications. You can get some really nice images out describing your workflow and how you've come to the conclusions that you have from your work. You can see on this one, again, two mounds there that you wouldn't visually really see as being that different if you were just looking at the grayscale view. You can see I've split them nicely there. So the 3D view is the first level of kind of user enhancement in terms of visualization that we've got. The second would be our false color overlays. Now these are really special and I really like these. So let me just bring this 3D view down so you can see it a little bit better. So the false color overlays basically allow you to change the color of your image, and they are different to kind of your brightness contrast score, which you can set per image within SpotMap. So if you were using two different sets of images from two different scanners with very different kind of contrast ranges that you need to adjust to get them in line for you to visualize them, we do support doing that separately for each image. And if you have a situation like this where you've got two similar images and you get the contrast how you want it on one image, if you click this button here, it will copy and paste those settings to the other image automatically. So if I just kind of bring that down here, you see it's applied to the other one, but these are slightly different. So the contrast ranges are going to be slightly different for each one. But yeah, if we want to go into the advanced interface, we've got full control over the kind of your classic histogram for contrast adjustment. You can see all of our data is around the bottom end here. These swatches here control the kind of the color overlays. Now, a lot of these are designed to kind of, if you imaged in a side eye, for example, and you want to show your gel or blot in the color of the side eye to make it easier to work with, so you can remember which one's side 3, side 5, side 2, whatever it may be. That's fully supported. But what I like the most are these different colorways down here at the bottom. So these are kind of completely false color overlays, but they allow you to really see very subtle changes in signal versus background. That's what they're designed for. They basically enhance the contrast of the edges extremely. So if I come back to, now I'm using this green overlay I've got here. Let's go here. So if I turn this back to black and white now, you can see these spots. This one not so much, but these spots are extremely faint. However, once I start putting the colorways on, you can see that actually we've got a fair bit of signal there. So you may decide to include that as a spot, and you see the 3D view is helping me work out where I want to set the edges of this box there by kind of modeling the data for me. So that's allowed me to see spots basically I couldn't see before. So obviously this allows you to get more data out of your experiment. Now, whether you would accept that as being a present spot or some form of contamination, something like that, is completely up to your SOP. What kind of minimum peak height or peak area or signal are you going to accept on site as a positive result or as the result of contamination, someone sneezing over the blot, something like that? It's completely up to you, but at least within our software, you can see that data and you can make the decision rather than that data being hidden from you and you never having the ability to kind of detect subtle changes like that. So that's the benefit of using the different false color heat waves that we've got. I like this one. It's kind of like predator vision, kind of like heat map system. And then the third method of visualization that we've got within our software to allow users to better work with their data is actually the ability to overlay the two images or multiple images that you're working on all at the same time. So if I just set this image back to kind of normal black and white, because otherwise it's quite distracting for the video. If I come to the overlay config section of the image, if I come down here to second image overlay, I can actually stack my images on top of each other. So what I've done here is I've basically made a multi-channel image. I've taken one image and my image on the left and overlaid it on my image on the right. By doing this, I can check for areas where there are spots in one image but not in the other, or vice versa. So the way this works is the spots on one image are colored in one color and the spots on another image are colored in a separate color. The idea being where there is overlap, you will see a blending of the colors and a third color will be produced. Where there are spots that are only present on one image but absent on another, they will only be purely, say, green. The inverse is also true. If there are spots not present on the gel but are present on the blot, they would be in the opposite color, which would be red here, for example. So you can very easily see where there are common spots, where there are spots that are present on both, and where there are differences between our gel and our blot, which obviously is what forms your percentage coverage score. It's what forms your antibody coverage step, and really allows you to validate your work and also work within the software. So those are the three main ways we've got to aid the user in kind of visualizing the data and working with the data and calculating an accurate coverage score. That's how SpotMap is able to reduce inter-operator variability and develop such accurate coverage scores for for the pharmaceutical industry. So I think that's pretty much everything I've got to tell you about kind of how we visualize data without going into the minutiae of it. If you've got any questions, or again, if you would like a free trial of the SpotMap software, if you're doing this antibody coverage work for your host cell protein antibody development, please get in touch. Go to our website. I'll put the link in the description below. Get in touch if there's any questions that you've got that I've not answered that might be good for another video, or you might just be interested in trialing out the software and asking me questions direct.